Hey guys, what is up? What is going on? Just wanted to show you this right here, the page 234 in the workbook, and this is a chi-square test for homogeneity. Chi-square test for homogeneity again. And one person had actually asked a really good question. How can I tell the difference in a chi-square test for homogeneity and a chi-square test for independence? All right, so very good question right here. So just going back to what we're actually talking about right here. In a chi-square test for homogeneity, we're trying to determine whether or not a distribution of a categorical variable differs for two or more populations or treatments. So we use a chi-square test for homogeneity. So in this case right here, there will be more than one, there will be at least two random samples, or it'll be at least two groups if it's not an actual random sample. But we're talking about two populations right here. So in general, we're talking about two populations right here. All right, if it's not a random sample, then it would be at least two groups or more. For independence, it's only right here. So going down just to compare that. For independence, this is to determine whether or not two categorical variables are related in a population. We use a chi-square test for independence. In this case, we're only going to have one sample or one group. In this case right here, this particular example has a survey administered to 100 randomly selected adults. Okay, so that's the biggest difference. Also remember, for a chi-square test for independence, you're trying to determine if there's an association between two categorical variables. All right, for homogeneity, right here, we want to figure out if there is, like I had said right here, if the distribution is the same or if the distribution is not the same is what we're trying to figure out right here. All right, so for homogeneity right here, there's no difference in the distribution of the categorical variable, or there is a difference. Okay, so there you go. But the biggest thing right here is that there's going to be, for a homogeneity, is going to be two or more samples, whereas independence is just going to be one sample. Okay, let's take a look here. This is for homogeneity. A recent study tracked the television viewing habits of 100 randomly selected first grade boys, 200 randomly selected first grade girls. So that tells me right there, all right, this is likely, it has a table right here, so this is likely going to be homogeneity. Each child was asked to identify which of the three shows is their favorite TV show. The following table summarizes the data. Do these data provide convincing evidence that television preferences differ significantly for boys and girls? All right, so we want to see if the distribution is the same or the distribution is not the same. So we say first, the distribution of preferences is the same for boys and girls, is the null hypothesis. The alternative hypotheses is that the distribution of preferences is not the same for boys and girls. And we're going to use alpha equals 0.01. Alpha equals 0.01, which was given right here. Okay? No problem. Plan. Okay, so for plan right here, first thing we mention is the actual test. It's the chi-square test for homogeneity. Okay. Next, we're going to write right here, we have random, and we had two random samples, didn't we? We have a random sample of 100 randomly selected first grade boys and 200 randomly selected first grade girls. So I'll just go ahead and write that down. So we have right here random sample of 100 first grade boys and 200 first grade girls. All right, awesome. Now right here we're going to go to 10%. Okay, so we have right here 100 is going to be less than 10% or 0.10 of all first grade boys. And 200 is obviously less than 10.10 of all first grade girls. This was a random sample, so we do indeed have to do the 10% condition. Okay, and then now we're going to do large counts. All right. For large counts, remember this is that all the expected values are greater than or equal to 5. So what we are going to have to do is we go to our calculator, right? All right, so what I'm going to do right here, on my calculator, I'm going to press second matrix. Okay, on A, I'm going to put the actual observed values right here. Now, this is a 2 by 3 matrix, right? We have 2 rows, 3 columns. It always goes by row by column. All right, no problem. So let's enter everything in right here. So we have 2, enter, 3, enter. Now we put all these values in here, 20, 30. Just press enter and it goes by row, 50, and now I'll go to the second row here, 70, 80, and 50, all right, into each cell. Okay, now we're going to press stat, we're going to go to tests, we're going to go to chi-square test right here. You do this for either homogeneity or independence. Goodness of fit was the first one that we did, remember. Observed is A. Now it's going to create our B, which is the expected, so we just press calculate. Now this actually, we're going to use this later, so this actually takes care of later, but right now we just need the expected value, so we'll go back to matrix, go to edit, go press enter for B, and now we have it all right here. Move this guy over. All right, perfect. So this, for large counts, first of all, I'm going to go and write down the expected values. Now, they said in the book you could also, if you want to, write them next to the original ones. You could do that and then make a key that says parentheses is the expected value. Or you can just create your whole new matrix. I'm just going to create my whole new matrix. It's up to you right here. This is boys, girls, and we're talking about right here Mickey Mouse, Doc Sutton, and Captain Underpants. Okay, no problem. So let's see here. So I'm going to put everything down. So we have 30. I'm sorry, wrote this down wrong. Sorry about that. We have, 30, 30.7. 36.7 if I round to 1 decimal. This is where I'm at. I'm at this guy right there. And then 33.3. Then we have what? 60, 73.3. And lastly, 66.7. Okay, so these are the observed values. Sorry, these are the expected values. Sorry, I'm saying all the wrong words. Okay, so no problem. So the key is right here that all of the expected values are greater than or equal to 5. Okay, and so we're good right there. All right, next we're going to go to, I'm running out of room here, we're going to go to the do step. We did state, plan, and now we're at do. Okay, let's do it. So this is already done for us. Guess what? So right here, we're going to go right here to stat, test, and go back to the chi-square test, and guess what? It's done. All right, calculate. There it is. So the chi-squared value is right here. Sorry. Okay, chi-squared value is 19.318. Okay, the p-value is 6.384. Oh, I'm sorry, times 10 to the negative 5th. Whoops, I already almost made a mistake. So this is actually 6.384 times 10 to the negative 5th. Whoa, so that means it's really, really small. And so we're going to actually just write down that's actually what? It's essentially 0, right? Isn't it? It's just 0.0000, and then, right, so it's going to be 4 zeros and then 6 I'm just going to round that to point. Yeah, 4 zeros and 6 right there. Okay, so there we go right there. And the degrees of freedom, of course, is 2. We didn't go over in class how to get the degrees of freedom if you don't have a calculator. Or maybe I said it really quick. But the degrees of freedom, sorry. To get that right here, you say the rows minus 1 times the columns minus 1. So in this case right here, it was a 2 by 3 originally, right? The rows was 2 and the columns was 3. So 2 minus 1 is 1, 3 minus 1 is 2. So that's why the degrees of freedom ends up being 2, just to let you know. Okay, you don't have to show the work for that, but just if there's a problem that asks for it separately, this is how you do it. Okay, and now we go to conclude. Okay, so right here, because the p-value, and I'm just going to go and put right here, you can put 0.00006 if you want, or it just essentially, since that's so many zeros here, I'm going to put right here these two squiggly lines means approximates to 0, is less than alpha, which was right here 0.01. We will reject the null. The p-value is low, so we're going to reject H sub O. Okay, so there is convincing evidence of whatever they asked for. So let's see, what was it they asked for? So there is convincing evidence that, I'm just going to go and parrot the actual original question. There's convincing evidence that right here, television preferences differ significantly for boys and girls. There we go. Okay. So there is convincing evidence that, that television preferences differ significantly, differ slightly, sorry about that, differ significantly for boys and girls. Now, notice I'm not saying for boys and girls like those in the study. I'm not doing that because it's a random sample. I don't have to. You only have to say that if there's not a random sample, so then you're just talking about people like those in the study. But in this case, just say for boys and girls, okay, because it's a random sample. All right, guys, have a good day.